So yeah, I mean, welcome to the session. Thanks for joining me. Um, let me quickly go over the format of this mock. It's gonna be an hour long. We're gonna start right away. Usually for interviews, they'll have like introductions, quick little round of introduction at the start. We're just gonna skip that. Right, we're gonna go right to the mock interview. Most of the time, you'll be given 45 minutes. In a 1 hour session, you'll be given 45 minutes. In a 45-minute interview, you'll be getting like 35 minutes to do the problem.
Right.
Okay, so we're gonna give you 45 minutes to do the problem. And as part of your work today, as I'm gonna have you control the time. All right, so you need to be aware of the time. You need to be aware of how far along you are. And then, of course,
Right.
depending on how well you do in that regard, we'll give you some feedback on that, okay? But today, you're going to be in charge of the time. And then
Okay.
the last 10, 15 minutes or so is going to be for feedback. All right,
Right.
so obviously in a real interview, they wouldn't give you feedback. They would just talk about some other random shit, but we'll give you feedback in that time. All right?
Cool.
Okay, so the first thing I'm going to do is for the first problem, oh, by the way, is Python your preferred language?
I recently switched to that, so yes,
Okay,
we'll
okay, cool.
probably have to
Let's try
look
Python
up.
today. If you find that
Yeah.
if it's too hard, we can switch it. But let's just try Python, okay? All
Yeah.
right. So I'm gonna paste the first question for you here. Some interviewers will give you it in dictation, but I'm lazy. I just want to paste. Also, I got a sore throat, so I don't want to talk. So
Yeah.
when I have a read, let me know any questions, and then we'll go from there.
Order. Group them together. Right. Sounds good. Are there going to be some like examples like you'd normally see on LeetCode, or no? That
For this one, I
not
want
in
you
this
to come up
case.
with some examples.
I see. Okay. Um. All right. Given an array of string stars, group them together. You can return the answer in any order. Group them together. I guess. All right. So I'll just start with example here. So let's say. I guess when you say group them together, are we wanting to return like a concatenated string or
That's a good question. So we'll be return the return type here will be a list of lists, where each inner list consists of all the strings that have the same anagram, or sorry, that are anagrams of each other.
I see. All right. Okay. So yeah, by anagram we mean that the we're talking about like aha and ha, right?
I don't think those are anagrams because they have different they have different composition of characters.
Oops, sorry about that.
Yes, that's
Ah,
right. Those two would be anagrams. Correct.
right. Okay. So I'm just gonna write some notes for myself. So to return a list of lists where each inner list is okay. So choose that. I was trying to come up with a decent example here.
Mm-hmm.
Okay, so the expected output in this case would be or he said order doesn't matter. Does that seem to be the
Yep,
kind of
exactly.
output that we're expecting? Okay. All right. So I guess how I think I want to go about this is to know. I guess we need to figure out which strings are anagrams, and to do that, I feel like I want to use like a frequency dictionary. I feel like that's usually a pretty good way of comparing the composition of strings. So, for example, aha would be H1. So both aha and would produce the same kind of frequency dictionary like that. And then I guess I'd have to figure out some way of, after mapping the array of strings into, a bunch of frequency dictionaries that have to somehow like figure out how many of each one I have, or how many duplicates I have for each.
Mm-hmm. So I want to just kind of steer us on the right track, make sure we're on the same page.
Yeah.
You didn't say this explicitly, but what is the purpose of having this dictionary? Like, so we have this, great, and then what's the purpose of it?
I mean, the purpose of it is I I'm not sure of the exact method of comparing these things, but it allows me to say that um, you know two or more anagrams are equivalent to each other. At least that's my hope.
Right. If they have the same dictionary, they'll be anagrams. That's what you're saying.
If that's exact, yeah, that's what I'm trying to say.
Okay. Perfect.
So yeah, I guess the plan is first iterate through the array and produce the frequency dictionaries. I guess in an array or something, and then hmm, I don't know. I guess yeah, I'm gonna just iterate through the frequency dictionaries and I don't know, somehow try and check in the rest of the list and see, if there are duplicates, and then yeah, this doesn't seem like a very good approach though.
I mean, one thing you'll need to do no matter what is to iterate through the array.
Yes.
Right. So that's a given, and then you're producing the frequency dictionaries, and again, what you're saying here is you're essentially saying you want to be able to identify in future iterations if some other string has an anagram that we already have seen, because we want to group them together.
That's right. Yeah, that's fair.
Right. So in some sense, what we're looking at here is we're looking at a situation where we have, like in our case, we have some anagrams, right? So these two would be anagrams, and
Yeah.
we want them to, like, we want to be able to access this array very quickly, because let's say in the end here, right? Let's say we have another one, right?
Yeah.
When we get to the last one, we don't want to have to iterate through all the groups of anagrams again. We want to be able to find out, hey, which of these three lists is the correct one to go to, right?
Mm-hmm.
So it sounds like what we actually need here is we need a dictionary which maps a anagram to a list of strings that have that as the anagram.
Sorry, I don't think I didn't follow you there at the end.
Yeah, no worries. So we're looking at here is we're looking at a way to iterate through our input and add each of these items to either an existing list or a new list.
Right.
Because every item has to belong to a list somewhere. It has to.
Right. Yeah.
Okay, so how do we figure out what list it should be in? Well, let's have maybe what you might call like a representative anagram, where let's say you have this dictionary. When you go through aha, you would have produced this dictionary and said, okay, this dictionary doesn't match any of the dictionaries we've seen so far, so this must be a new list. So aha will go into a new list.
I see.
When you go through aha, you produce what did you call here? You called it a frequency dictionary, but this
Yeah.
frequency dictionary would have been the same one that aha had.
That's right. Yeah.
So it sounds
Okay.
like
I think.
the
Yeah.
defining factor of this group of anagrams is this frequency dictionary.
Right. Yeah. Um, so I guess as you're saying that, I'm thinking maybe it's probably a bit naive, but maybe what I can do as I iterate through the array of strings the first time is create some kind of data structure with these frequency dictionaries as keys and the actual strings as or sorry the strings in like lists as values. So that would look something like this, I guess, as I'm iterating through.
Mm-hmm.
So, yeah.
Yeah, that looks
Got a
good to
little
me.
bit.
Yeah.
Okay. That yeah, that seems fine. I'm still wondering like that's okay. Maybe I'll just make a helper to actually compare. So I think I know how to form the frequency dictionary. I think I'm still a little iffy on like how I'm gonna compare the frequency dictionaries for equality. I think maybe I'll just write a helper for that to say like something along the lines of like I'll have to iterate through the string, and for each character I'll have to say, okay, is it in the frequency dictionary, and then I'll have to make sure it exists in the same quantity, if that makes sense. So maybe, yeah, I'll do that as I write the helper. So all right, so we're gonna iterate through the array and produce the frequency dictionary. I don't know what to call this thing now. Frequency dictionary. Yeah. This value. Okay, so let's call this anagrams. And say for stir in stirs. Maybe I'll write a helper to create the dictionary.
Okay, I'll give you that as a key type.
Oh, thanks. Oops, sorry. My co-op. I'm writing a lot in JavaScript, so forgive me if I write semicolons.
That's okay.
Okay, so then we need this other, call this thing frequency. It's got frequency dictionaries as keys and arrays of strings as, let's just call it anagram. That's the syntax. So once I my frequency dictionary, the next question is it already in this anagram dictionary? So maybe I'll just write a helper for that. So
Can I
self
suggest use
dot.
a different variable for the
Yeah.
string because that's a type in Python.
Oh, sorry about that.
You can just use s. Yeah, that's fine.
Yeah, thank you. So self dot and this is going to have to take the if it does already exist, then I guess what I'm going to do is key into the dictionary, and this is, oh, sorry, not incrementing there. I need to add the string to the list. Let's copy this. Let's append. So if it isn't already in there, then sorry, I'm just looking up the primitive to add a new value.
Oh yeah, in this case, this would already return you the list, so you just do like dot immediately, right?
Sorry, say it again.
If I understand here, you're trying to if it is in a dictionary, you just want to add it to the list.
That's correct. Yeah.
Right. So
If
in this
it's
case,
not, then yeah.
right. So in this case, this expression would already return you the list.
Right. So
So
that
we don't need the equal there. We can just do dot append.
Ah, I see. Okay. So I've wished for a couple helpers, but assuming all of that works, at the end of this, I'm going to have this anagram dictionary, which has a bunch of lists. So to form my final answer, let's call this output. I guess I'm just going to iterate over. So we have this kind of. I'll just look this up. Yeah, that is a primitive. Oops, that looks like a package or type. Okay. So I'll get started with this first helper, the get frequency dictionary. Takes a string, it returns. I'm not sure if I've got the syntax of this signature correct. My apologies.
Yeah. Don't worry too much about the signature. You can just
Okay.
yeah.
Okay. So to produce a dictionary. parse ES iteration accumulator here. It's basically the same kind of. I'm sure there's a better way of. Sorry, I'm just looking up the primitive. I'm pretty sure this is like get primitive, where you can either. I think it's like this. I'm just looking it up.
What are you trying to do?
What I'm trying to do is, okay, say if the character already exists as a key in the dictionary, then increment it by 1. Otherwise, just set it to 1. I think it's.
Oh, I see what you mean.
This or something.
If you want to just get, so you want to get the, sorry, just don't forget, you want to see if a key exists in the dictionary.
Yeah, so, if my, like if my word is ABA and I'm on A, right, and this is the first character that I'm iterating through, what I want to do is say, if it doesn't exist in the dictionary, then I just want to add it to the dictionary with a value of 1. But if I'm on this third or the second A, then I want to increment the value by 1.
I see. Yeah, you can use a syntax if key in dict. And also, you probably shouldn't use dict as a variable name because that is also a keyword.
Oops, sorry. Yeah, should recognize the coloring there.
Yeah, so in this case, your key would be your character, right?
That's correct. Yeah. So if the key is in the dictionary, then so I guess I can just use this syntax.
I think you got it backwards. I think if it's in the dictionary, you want to increment it by 1.
Yeah, I did get it backwards. Sorry. Yes. All right, and then just going to return that. So now I've got that here. Now I need this other helper. And right, so I guess the question here is, how do you compare? I guess I'm gonna have to iterate through the keys in Anagram dictionary. So
can you use this syntax again? Is this possible for you?
That's a good question. I can look that up. I don't know if that comparison there, that in keyword, will allow for proper comparison of a dictionary. I mean, I can, if I make that assumption, then
Yeah, why don't
can
I
I
make that assumption for now? Yeah,
we'll make that assumption.
Yeah.
Okay. So yeah, I guess all we're doing is returning true or false here. So oops. Okay, so then here we said if it does exist in there, then we're just going to append the string to the list, which is the value in that dictionary. And then at the end here, we collected all of those lists into another list. So we should have our list of lists, and then we've returned it. So I think I am finished the implementation. Should we discuss like time and space complexity or?
I think I just yeah, we can go there in just a second. I wanted to ask
Yeah.
one more thing here, which is over in this scenario, you are saying that you are setting the value of this, which is a list, to this,
Yeah.
right? What is the return type of dot append?
It should. What I want it to be is an array of strings.
Okay,
I can look it up though.
because I don't think append returns itself.
I see. That's a problem then. It returns none. It modifies the original list in place.
Yeah, so I might have misled you with this hint. I think this one should be the dot append just directly. And
I
then this
see.
one you might need to set as a new list containing only the string.
Right.
Yeah. Okay, cool. All right. And can you just quickly walk me through what this little snippet's supposed to do?
So the purpose of this, so this output here is, it's an iteration accumulator to collect all of the values in this anagram dictionary, which we are hoping to be our groups of anagrams. So we would have our aha and ha. We would have another entry, which would be in this basically. Does that make sense? Or?
Yeah. What's the return value of dictionary dot values?
It's I mean, I guess my assumption was that this will allow us to iterate over the values in the dictionary, which are our
Yes, it would.
yeah.
But what you're doing is you're iterating through the values in a dictionary and then putting the value just iterated over right into the same list. Is there a reason we're not just returning anagram dict dot values?
Oh yeah, that's a really good point. I guess that would be a list of lists already. So yeah, I can totally.
Okay, cool.
That's a bit better.
All right, cool.
Sure.
So yeah, now let's go to the time and space of this function.
Okay. So as for the time complexity here, we are iterating over all of the strings and stirs. So that's O of n. This get frequency dictionary is looking at every character in string. So it looks like we've got some nested loops there. And the outer one is O of n. And the inner one, I guess it depends on the length of the string. So maybe I would, and I mean the length of the strings could vary. I'm not sure exactly how to describe that. I'm tempted to say that we could say this has a cost of like O of M or something like that. But of course, if the length of these strings is arbitrary, then I don't know if that's the most appropriate description. But yeah, I guess overall, that would be multiplicative. So it would be O of n times m so far. And then this one here, this does frequency dictionary already exist. Pretty sure that that one is going to have to look at every entry in the anagram dictionary, which would have a length of at most n if there were no anagrams. So I guess that could dominate over this get frequency dictionary, and since they're sequential, I guess it depends. This one could dominate, or this one could dominate, so it'd be either maybe O of n times n or O of n times q, let's call it. And then the rest of these operations, like just returning and this indexing into the dictionary here and here, those are O of 1, so non-dominant. So yeah, I guess the overall time complexity I would say is either like O of n times m or O of n times q, depending on the scenario. And then as for the space complexity, we are making this anagram dictionary, which again, if we don't actually have any anagrams in our list of strings, it could have a total length of O of n. And then these frequency dictionaries, I feel like a frequency dictionary is like constant space complexity, because there's like 26 or 27 characters in the alphabet.
Yeah.
So yeah, I feel like the space complexity is O of... Is it though? Because space complexity, if I recall, it's space that we're using that isn't used in the output, yet we are outputting the values here. So I'm actually not 100% sure about that.
So if you were to include this, what would it be?
If I were to include in the space complexity, I would say O of n. And if we're saying that that's not a part of the space complexity, then I would say the frequency dictionary. Yeah, I feel like then the frequency dictionary would dominate, because that's definitely not, it's not a part of our output, right? And I think it would be constant space, or I don't know, O of 26 or O of 27, whatever the case may be.
Okay, makes sense. All right, so we have a bit of an awkward amount of time left, so I think I'll just spend a bit of time here revisiting this problem and improving a couple aspects.
Right.
So the first thing I want to bring to our attention is that in Python, sorry, you said that you mostly do JavaScript, right?
That's right, yeah.
Okay, so in Python, literal dictionary types like this, if you see where I'm hovering, like literal dictionary types cannot be keys to another dictionary. And the reason is because dictionaries are considered mutable, and keys are not allowed to be mutable.
Okay. That makes perfect sense.
So the first thing I'm going to ask you to do is to change your solution. You can still use dictionaries some way or another, but please make the key type to your anagram dict not a mutable key.
in that, yeah, in that case, I guess maybe what I could do is make the key a since anagrams have the same composition and frequency of characters. Maybe I can have the keys be strings that are in lexicographical order, or you know what I mean.
Yeah.
Yeah, and I would have to add some kind of helper or functionality to generate those um, alphabetically ordered strings. Um, so then it would look something like this, if that makes sense.
Where are you?
Line
Oh, you mean
24.
this? Yeah.
Yeah,
Yeah. Yeah, that makes sense.
yeah. Should do me to try and fix the implementation, or
Yeah.
not enough time,
Yeah.
I
Yeah.
guess. Oh yeah.
I think we have time to do
Okay.
that. Yeah.
Okay. So in this case, we're not going to be getting a frequency dictionary. We're going to be getting ordered string. I think we could still. Can we still use our? Yeah, I'm trying to think. How do you? Can I just use sort? Would that primitive work? I'm not 100% sure. I don't know if I'm allowed to ask you.
You can ask me. You can't use sort on a string, but you can use sort on a list.
I can use it on a list. I see. So I guess probably a bit of a naive approach would be listed. Okay, so then I'm just gonna push each of these into the sort, and I assume there's some kind of join in Python.
Yeah, there is, but I'll give you the syntax. You put it up front.
I put it front, thanks. And then
Well, I believe you need to use sorted because you want the return.
sort. I see. So yeah, then um, we so it's not.
Do you think you could simplify this to not use a helper? Because I feel like this logic should be pretty simple.
Yeah, it is. So if yeah,
Okay. Does this change D time complexity?
does it change the count complexity? So I'm still iterating through all of the strings and stirs. So then I'm still looking at every character in each string. So, whatever that cost is multiplied with O of n. And if ordered, yeah, I'm not 100% sure about how much this operation here costs. I feel like, or wait, it should just, I think it should just be O of 1, right? Like, I don't know exactly how it works under the hood, but I assume that if you just try and key into this dictionary, if you don't get it, like if you get none back or something undefined, then it's not in there. So that's O of 1. So I guess it would change in that previously this could have been a dominant kind of operation, but now it's clearly going to be this get ordered string one. So it's
Okay.
O of n times whatever the cost of this is.
What is the cost of get ordered string?
So it depends, I think, on. I feel like it depends on the length of the string that we're looking at. And yeah, if you have a. So I don't know, like in our example here, I mean, these all have the same length, right? So in that case, yeah, it'd be O of n times, well, I guess this would be constant, but you have one like, really long one, and then you have a short one, and then you have a long one. Um, I don't know if we can take the average of their lengths and say that it's O of n times that average length.
Okay. Well, the dominant factor, as you said, for this function would be the sorted function.
Right. Yeah, that would be more expensive than iterating through the list.
Yep. So if you take that into account, how would you describe it?
Uh, well, I think if I remember correctly, the sorting algorithms are all like at best n log n, if I'm recalling correctly. But
Yeah.
again, like n here, it depends on the it depends on how long the string is. So I guess again, I want to say maybe it's like the average n of all the strings log the average n of all the strings. Does that make sense?
Yes, but if you were to do a big O definition, how would you categorize that? Because um, the big because like kind of as you said, right? If you have an average of a very long one and many short ones, the short ones would be far shorter than a long one. So the average wouldn't be the best way to categorize that, right? I think for big
Mm,
O, you would take the worst case. So you would say the worst case in this context would be the longest string available.
sure. Yeah, that makes sense.
Okay. Okay, cool. Does the space change?
Um, so I am now. I now have this variable here, which is going to be in the worst case the take up space commensurate to the length of my longest string. So yeah, that could be however long. Uh, so I guess that, and I think I said before I wasn't like 100% sure about whether this anagram dictionary actually counted towards the space complexity because I am returning it, like at least its values as part of my output. Yeah, I want to say that this is going to be so the big O of the length of the longest string is going to be my space complexity.
Okay, cool. Okay, cool. Let's call it here.
Okay.
And this is a good time to call it. I wanted to kind of go through some feedback and questions. And usually when I do this kind of thing, I start by asking you, how do you think you did? What do you think were some strengths and weaknesses?
Well, I mean, right off the bat, I feel like I need to review my time and space complexity. Like I think I have been doing a bit of practice with it, like after each question, trying to sort of think through it. But I think I was a bit rusty there for sure, especially when it came to like analyzing the nested kind of loops and trying to figure out what the time complexity of like this helper here was with like strings of varying length. I think I was missing some fundamental knowledge there, which you helped me through and said, it's the longest string. We're always, big O. We're worried about worst case. And then, yeah, initially trying to figure out like my sort of plan. I think using a frequency dictionary. I don't know. I guess I've seen a lot of problems where that's a useful technique. Maybe I jumped to that too quickly without. Maybe I should have asked you more questions about whether that was valid or appropriate approach. But
Mm-hmm.
yeah, I think I had a bit of trouble like working through this sort of high level approach to solving the problem. Like,
Yeah. Okay. Okay. No, I think you got a couple good points in there. Um, let's start at the beginning, right? So let's start with what I would consider to be like not even about the specific problem, but more about the approach and the strategy. Okay. So the first thing to note is that for live interviews, your approach and strategy should be different than from when you're doing OAs and like quote unquote pure lead code problems, right? For live interviews, there's like another component onto that, which is the interviewer. So things that should change whenever you're thinking about like OAs versus interviews is how you're going to leverage the interviewer. The first thing that should probably, I would say, like you should look at is exactly what your like pre-game plan is, right? So a couple of things that should come out immediately for this kind of thing is ask questions about the edge cases, right?
mm,
For example, what are the valid characters, right? Is there
mm,
upper lowercase? Is there punctuation?
ah,
Stuff like that. What if there are, what if the strings are empty? What if there are no strings, right? Some of these edge
right,
cases should be coming out immediately, right? And the thing is
right,
that that doesn't depend on the question, right? If it's a right, it doesn't depend on whether there's anagrams or not. Like those questions are valid for any question that involves a string type, if you notice that.
right.
So those should
Yeah,
come out
hundred
immediately.
percent.
And then the second thing is sometimes I give you the example. If it's like a difficult problem, they might give you an example just to kind of guide you along. But even if they don't give you an example, you should probably think of one yourself, right?
Right.
Basic stuff include you can do some edge case examples. You can do a happy case. So what we did today is basically what I would consider a happy case example, right? Like nothing weird, very simple to walk through, talk through, etc. Um, so that's good. Now the balance here is that how much time do you spend? Because you don't want to get caught up spending too much time on examples, but you can imagine if you didn't have a good example or two to think about, you might end up being slower in the actual implementation. So there's a balance there,
Right.
and that is a skill. Now, the first thing to do with the implementation, which is to talk about, comparing anagrams, that is the crux of the problem. That is good. You did need a bit of help with putting with the idea of using the dictionary as keys. I think that
Yeah.
is a pattern which might have been new to you. So that's something you could definitely practice more, get used to. That being said, I still think that even if you haven't seen the problem before, I think it's still reasonable for you to come up with it yourself. Right? The pattern that you should be identifying here is all the strings in this list, the anagrams, they share a common characteristic. So if you want to group these guys together, you need to find a way to identify the common characteristic quickly, right? That is not just for anagrams, that could be for any property of any other type, right? So that's a pattern that you should be thinking about, and this is a common way to do it. Now, in this case, because you're unfamiliar with Python, right? I wasn't concerned with using dictionary as a key. That's a small detail, right? Someone who's more familiar, I would have expected to identify that and go like, hey, this is a language which does not allow that, and so we need to have intermediate data type. So let's just jump forward a bit, right? What you ended up settling on was having a sort of string type. That is totally fine. But one thing that you should have maybe recognized is that having a sorted string type is actually um, it's technically speaking not great because you do incur the sorting complexity, right? So what I would have expected a strong candidate to do in that case is to get here and say, oh hey, we're actually sorting. And sorting is less efficient than we were doing before, which is just iterating through the list with constant operations, right? One thing that could have been done here, and again, I'm not saying that you should have done this right off the bat, but one optimization you could have definitely made here is have have your own encoding for what a string should be, right? And this is why it's so important to know about the problem space, the edge case ahead of time. Let's say for this problem, I think this problem LeetCode, I think it actually only allows lowercase letters, right? So, you could have done something relatively simple. Like for example, you have a string. Let's say just A, B, just to make it really simple. You can encode this uniquely as A2, B1. There's no other string, or not other. There's no other anagram, which could give you, which to do this one for example, which could give you the same key. Right, so this would be A2, B2, as an example. So that's like an example of what you could use as a key. This would not require sorting in this case, but you could, like there's differences. There are things you can do. There's another thing you can do, which is Python specific, which I don't expect people to know, which is with the idea that you can actually turn, that you can actually turn a mutable data structure like a dictionary or a list into an immutable one, and that is with the notion of what's called a frozen data structure. So you can go check that up after, but so that's something which I think can be improved on. It's probably going to come as more of an experience of going through these follow-ups, right? Think about it in this case, it's one thing to get the optimal complexity on your first attempt, but it's a different skill to compare complexities and say, could I have made the follow-up more efficient? Right? That problem doesn't depend on you getting the optimal problem in the optimal solution in the first case. Right? All right. So, lastly, I would say a couple of things to call out here. I mean, I think what held you back on the speed here was the familiarity with Python. Right, I think that is something which definitely comes with more practice, doing more problems, writing more projects in Python. You get more familiar. I would say the level of Python you were showing today, I think would be okay for roles where Python is not an expectation. But if the roles were looking at Python, then I don't think this would be a good reflection. Right. So I would say for roles that maybe are looking for Python, you want to either just stick to JavaScript, which would be less of a signal to the interviewer that you're good at Python, but at least they wouldn't know that you're bad at it, right? So I think it's a different thing going on here. So just be aware of that. I think it's okay if the role doesn't care for Python, but again, your mileage will vary depending on the interviewer and their personal expectations, right?
Yeah, can I ask a question, Leo? Like, I switched to Python just because it seems like everyone says, oh, that's, it seems to be the most popular language for LeetCode.
Yes.
And so I figured, but I figured I'd just start using it. But to be honest with you, like, even in JavaScript, I would probably have to look up primitives. I guess my question is, do some interviewers want the interview to be done in a specific language, or are they mostly like okay for you to use what you're strongest with? Or
that's a great question. For LeetCode interviews, it's generally, I think it's the vast majority of the time, it's okay to use any language, anyone that you're strong with. The reason that I would say between JavaScript and Python, I would lean towards still learning Python is because JavaScript as a language is not complete for LeetCode. So there's some things in JavaScript which are in my opinion completely unusable. The first thing is that it has basically no data structures. Outside of a list and a map, there are no data structures in JavaScript. I mean, by the way, feel free to correct me, but that's my understanding. There's no trees, there's no tries, there's no notion of any sorted data structures, and graphs, you have to hand roll all those yourself. So it's okay for list, string, basic, like hashing questions, and everything else. I think it's pretty. It's gonna hold you back.
Right.
And then I think in JavaScript there's a lot of quirks. So for problems that require you to run the problem, this is me personally speaking, I am not confident enough in JavaScript to know if I got all the quirks. So, for example, one of the things that is related to this problem is in JavaScript, you can use mutable, what do you call it? Mutable structures as keys and maps. I'm pretty sure JavaScript you can use anything you want as a key and a map, but that's beside the point. But the issue is when you use a like non-trivial or non-primitive key in JavaScript, to check if your map contains that key, you need the same instance and not just the same value.
Right.
Right.
Yeah. To be honest with you, I wouldn't know. I wouldn't know either. But I guess What I hear you saying, correct me if I'm wrong, is like I need to know more about the basics of the language. I guess I've been telling myself that remembering primitives and syntax isn't like hugely important. What's more important is like the approach and the thinking. But I need to be better than this for sure.
Yeah. I think it's worth your time and effort getting into the Python ecosystem a bit more, because it's gonna like Python is not just for LeetCode. You could use it for all the different interview types. So Python is also quite good for OOD interviews as well.
Right.
So I think it's worth the investment to learn. Basically, is what I'm saying.
For sure.
Any other questions? Open questions
No.
for you. Okay.
Or let me just see here. No, I think that was really helpful. I really appreciate the opportunity once again.
Okay. Cool. Then thank you for your time, and I'll catch you in the future. Take care.
Okay. Thanks, Leo. Bye.